ఆడకపోతే మైకే కట్టేస్తా ఇది ఉంది కదా 1 to 8 అందరికీ చెప్పండి మనకులాగా మళ్ళీ 1 తెలియదండి. రేపు ఉందా ఇదే క్లాస్ సాయంత్రం పెడతా గ్రూప్ లో మళ్ళీ మెసేజ్ అన్ని ఇవాళన్నీ వాడేస్తున్నాడు సిమ్మరల్ 1 2 అక్కడ ఏ రూమ్ ఉంటే ప్రతిదీ వాడేది థామస్ కిందకు వచ్చావు आदित्य कैसे పడిపోద్దన్న అది పడిపోద్దాను ఓన్లీ అలా పెడతారు సరే లైవ్ లో జాయిన్
after distributing now computing paradigm. So cloud computing. The cloud computing. Internet, what is the name is internet computing? All the resources are available, not at your end. The resources are this side. We'll make use of that resources by using internet connection. By using an internet connection. So that we can see we are accessing, performing, we are processing data of our cloud side, say cloud computing, those resources are accessing by using internet. Can say internet cloud. The internet cloud of resources. Cloud computing is an internet cloud of resources. KPI is centralized distributed computing. As we discussed, it sometimes it is centralized, sometimes it is a distributed systems, like acting as a central distributed computing. As a cloud applies parallel distributed computing are there. And as we have discussed parallel computing, central computing, and distributed computing, this cloud can satisfy all this. Sometimes it also acts as a parallel computing. In the parallel computing, as I said, it is tightly computing. This is tightly computing, loosely computing, tightly coupled, loosely coupled. Loosely coupled. Tightly. Just before the week, it is loosely coupled, tightly coupled. So remember once again, loosely coupled in the sense, if anything is changes has been done at server side, and that will not affect on the other users. నీ దగ్గర ఏమైనా చేంజెస్ వేరే వేరే వాడికి ప్రాబ్లం లేదు. It is loosely. Tightly coupled in sense, it is restricted. Like tightly coupled in sense, just remember the different way. Tightly in a sense, everything is under control. ఏది ఒక్కటే మొత్తం అందరికి అయిపోయింది. ఏది ఒకటి something has been changed into that, and everyone will get affected into changes. So tightly coupled is something but like parallel computing as of like parallel tightly coupled. One memory can be shared of different processes. So our memory, anything is changes has been made into that memory. A processor one processor memory get affected. Loosely coupled, no problem. We can just leave it as is. You change according to your wish at your end. That is not recommended to others. Loosely, right? So clouds can be built with the physical or virtualized resources on the large data centers, internalized or distributed. The last point is that the cloud method, it is having set of different kind of resources which every user cannot build. So every user at another burden of thing. ప్రతి ఇంట్లో 150 కేస్ పెట్టుకోవాలి, 150 members was all petroleum. So every user cannot maintain the requirements of all the requirements that users get. So cloud can be made up of with those type of all type of resources. It is built with the particular resources for the large data. Some space it is sufficient space available to maintain different kind of resources. The utility acting as a centralized and distributed computing. It is a form of utility computing or service computing, distributed computing system. So utility computing we need to discuss. So it is also acting as a distributed computing, service computing. So before we need to discuss this utility computing, there is the two points we need to discuss about distributed and cluster computing. As cluster is a set of cluster data, cluster is a group, collection, right? And distributed is nothing but the work is distributed, the single work is distributed to more than one user. Same task have been divided, same task is divided into three parts. Yes, I am giving one task to you, and you said it is very complex to solve. Then I said you divide and share the others. You partition that one and share to some two more members. Then all the three members can solve that. This is distributed. So the second point here, cluster refers to a group that are grouped together to achieve the same business and can be considered as one computer. Whereas cluster, it is the same business task. It is the same complex problem can be divided into group of servers. That can be a group of servers connected as a single unit. The first distributed equals to splitting your business into different services. Same problem can be divided into sub problems, and sub problems are individually can be solved separately. When in the divided the problem which is very complex problem to solve. As and when you feel it is very complex problem, can be divided into sub problems. And separate problem divided is separate problem here. And all the solutions of problem combined is a unit divide conquer. Right? So that is a distributed process and cluster computing. Well, wherein the applications of anyone can tell me abbreviation of HPC. HPC. High performance computing. PC, HPC. HPC. Betul tak? Baru HPC abbreviation betul. HPC high performance computing. High performance computing. Generally, this is a high performance computer. High performance computing and HPC high throughput. Throughput will specify one day. Time period will in a 1 minute of time. 1 minute of time. The time period 1 day, 1 hour, 1 second, 1 year. In specified unit of time. How much task has been completed by the process? In 1 minute of time. 1 minute of time. Then you get it. That is your throughput. And your capability is 10 rupees you can eat in 1 minute, and somebody else will eat only 5 rupees. That is 1 minute of time is the period we have decided. Based on that, we decide your throughput. Or 1 hour, or 1 minute, 1 day. So, high throughput computing. How throughput computing in the sense, high throughput computing depends upon the number of processes. So, when the processors are more, throughput will be increased. Definitely. Right. So, with knowledge and memory capacity, remembering capacity is more, and you can remember more subjects or more data. If it is memory power is less, then obviously you will remember very less data. Right. These applications of this LPC and HTC, where you will those are applied in a different domains. The left hand domain is domains of the first one is science and engineering domain, second business, education, services, industry, and healthcare domain, and the next one internet web services domain, and also government applications, and the last one mission critical applications. there are different domains in the HPC, HTC will be used. So, the first one is here, science and engineering systems. These scientific simulations, geometric analysis, etc. And education, prediction, global warming, weather forecasting, etc. This HPC and HTC. In scientific applications, like if it is scientific application or geographical representations or weather forecasting, high performance computers are required. Forecast what happens in the video, right? So those applications we use HPC and sometimes on HPC. Second one is research and education services, that is telecommunication, content delivery, and e-commerce, banking sectors, stock exchange, like transactions, processing, and also air traffic control, electronic overlays, distance education, healthcare, hospital, automation, telemedicine. These are the different cases. So there is a domain is specific application. The domain name is education. In the left side, the domain name is education or business services. So we can say it is a telecommunication, content delivery. When it is education is a one domain. In education, how this increase is will be used. That is the delivery of content of the lectures, video lectures, online classes. We need to, if it is online classes, definitely high process computing is required. And further, this is a specific application we can say in education system. Right. And education system, telemedicine system. Also, there is specifically used in telemedicine system. Nowadays, the most popular. They we require HPC and SC system. Next one, internet and web services, and also government applications. Internet search, data centers, decision making systems. Internet search, obviously, we are expecting a Google search. So whenever you are searching some query, we are expecting immediate answer, response from the Google. If it is still it is buffering, then it is performance is very low. So whenever you click on enter keyword, then it will getting answer. So that means that performance of the system, that performance of the cloud will be very fast because it is perform and it is better with high performance services. And also that this last one is tele decision making systems. In a decision making systems like nowadays when you see AI, AI and deep learning ML. In the AI, so we need to take a decision according to the data. AI machines will learn by after training the data, the AI machine can perform and can read the data, given data, it acts according to that with immediately. So that is decision will be taken as per the reading of data with the previous experience, previous training model. So those are the AI machines. These HPC systems are more useful. And in the government sector like traffic monitoring, war containment, cyber security. So the specifically it is a traffic monitoring system. So based on the traffic, so we need to perform action regarding to control the traffic and also cyber security to overcome the frauds happening in the online. And the last one is most important, mission critical applications is a one domain which is used in military purpose and also command control, intelligence system and crisis management. This is the last one. Now we go friends towards utility computing. As like cloud computing, utility computing is a new payment. As utilities, utility payment, what do you mean utility payment? In your phone pay, in your phone pay, payments you can pay for different purposes. Credit card bill you can pay. Perfect pay the credit card bill. What will you DTH, your Tata Sky Airtel, they will visit. Fiber optics, Geo Fiber, Act Fiber, bill payment nature, electricity bill, payment, water bill, can be paid, right? So, mobile recharge. that is mobile, we can also pay. So there are different kinds of facilities available with this. Means utility computing is nothing but like see the inside of jungle. Then your home, different services and different utilities are there. Like electricity utility, water utility, uh, computing utility, gas utility, and for different. These are the utility bills you can pay. How we pay a gas bill, how electricity bill, how much of electricity bill will pay per month. For example, can you say that what is your last month electric bill? Do you have an answer? Do you have an answer? What is the last month electric bill? One of the say 200. What is the next month electric bill? What is the amount we need to pay next month? Last month you can directly when you have received what is the last month? 200. For next month we cannot say because we're paying for gas bill also sometimes varies, right? Water bill based upon the meter reading, right? So what is the grocery amount? Credit card bill. These we cannot predict future because those are the bills generated based on usage. Okay. If last month you have used only 200 units because of that reason, your bill is 1400, for example. And this next month bill I cannot say that can say after 1 month only depends upon the number of units consumed. Okay. So you are paying your bills based on your consumption, based on your consumption. So consumption, we are paying utility bills. In same like utility computing is also like all the resources are there. The resources are used based upon your usage. For that, you are paying based on your usage. Then that is called cloud computing. Then that is called utility computing. Utility computing create service providers makes computing resources, infrastructure management available to the customers as needed and charges them for specific usage rather than a flat rate. Okay. If it is collectively generated based upon the specific usage, the last month we have used 400 units, and one is cases that most of the cases transferred. So then the consumed units may be only 100 units. Then weight is varies. So they will charge that. They will charge based on the usage. The same way, there are set of resources that are the resource based on the usage of the resources. We need to pay as per your usage. Here, there is left hand side, all the computing criteria. The first is web services, data center, utility computing, service computing, grid computing, P2P computing, cloud computing. Among all these things, the technology covers by using HPC and HPC, the utility computing is more upon cloud. Utility computing is more flexible upon cloud computing. And also the where the after different computing paradigms, so we have a topic called as Internet of Things and Cyber Physical Systems. As I told, Internet of Things will work based on the sensors. Okay. Based on the sensors, when you enter into the room, the switches of light and fans will be automatically on based on sensing. There is a sensing device installed in that sensor and coding will be embedded into that device. Based upon the sensor, it will be work automatically. And the device is called Internet of Things. The Internet of Things is nothing but it is a one device, physical device which is, but it is working the based upon the sensor device. The first point here, Internet of Things is about connecting things to the internet, eventually to each other. So Internet is a network connection of everyday objects, including computers and screens. That's good. The computer also sometimes it is your mobile log will be opened by sensing fingerprint sensor device, face recognition, right? So different automatic door open, automatic door close will be done by the sensors only. And normally మనం lift లో లోపలికి డోర్ వేసుకోవాల్సి డోర్ closing over there, few seconds. So if you want a person who is coming from Bangladesh, you will see want to speak door open. There is a one hand we need to keep. So hand will test the door closable, right? It is better close. There is object or even being. It is by sensing that it will not be closed. Those are the sensor devices and working towards internet. And the last one is the cycle systems or integration of complex network with physical system. So here this cyber physical systems are integration of computation, networking and physical processing. So these are the integrations. There is a relation or we can make a relation between these integration computation with the network process, physical process. When it is the cyber security or we can say provide security over the internet, then physically we need to connect them. Physically means that the processor which are outside other side of that we can say is the cloud. Those can be communicated with the net, internet. Whenever we are communicating or establishing a sharing a message to the internet, make sure that security should be provided. So that is the network. By network, we have provided security by using firewalls that are both inside. So in between there is a wireless connection. So we cannot accommodate, we cannot provide, for example, if one basic thing is to provide your end at your device, your client side, one firewall can be detected always. At the other server side also you provided the antivirus we can say antivirus. Malwares will be protected. So these are the topics about the first part of your one. In this, see the three part. Age of internet computing. In the age of internet computing, we have studied about HPC and STC, right? And the next one is scalable computing trends and paradigms. In that, we have studied about different paradigms like this central computing, distributed computing, parallel computing, cloud computing, utility computing, right? And the Internet of Things and working in the sensors. By here, just to make a note of definition, once note of this scalability first point, please. Everyone should note scalable point. Note of the scalability or keep adding scalable computing over the internet. Scalable computing over the internet. Under this, write down the first point. Scalability is the ability of a computer. Yes, the pattern of particular note of transformation customer brings the scalability is the ability of computing applications, ability of computing application or a product, computing application or a product. The product may be a hardware software, kind of credit, ability of the computing application or a product, variable of hardware or software. Scalability is the ability of the computer application or product to continue to function well, to continue to function well. When it is changed, when it is changed, function well. When it is changed in size or volume, changed in size or volume, in order to meet a user need. In order to meet a user need. Say, user also need. Also, it may be size increase or decrease. The actual completion, actual work should be done as usual. So users sometimes users only 5 users are accessing. Next time it may be 10 users are. Such a way it will be services will be provided for not only for restricted. It should be elaborated. It should be so again scale up, scalability, scale up and scale up. Scale up in the sense its volume of may be increased, scale up in the sense it may be decreased. Excellent. The age of internet computing. The age of internet computing. Age of internet computing. Under this heading, high performance computing. Regular HPC. HPC. Age of internet computing. Under this HPC. HPC refers to the use of HPC refers to the use of supercomputers and parallel processing. Use of supercomputing and parallel processing. Use of supercomputing and parallel processing. So complex to solve complex computational problems. To solve complex computational problems. Complex computational problems. So it focuses on maximizing. It focuses on maximizing processing speed and efficiency. Processing speed and efficiency. Applications of HPCR, high performance computing. Applications of HPCR. First point, weather forecasting, drug discovery, climate modeling, climate modeling, AI and machine learning. AI and machine learning. Next one, HPC systems, high throughput computing systems. High throughput computing systems. Under this item, it builds with parallel and distributed computing. It builds with parallel and distributed computing. Built with parallel and distributed computing technologies. Distributed and parallel computing technologies. And it upgrades the data. It upgrades the data centers. It upgrades the data centers using fast servers. Using fast servers, storage systems, storage system, and high bandwidth network. And high bandwidth network. Next slide. There are different competing paradigms. There are different competing paradigms. The first one is distributed computing. First one, distributed computing. Number two, parallel computing. Number three, cloud computing. Cloud computing and grid computing. Grid computing. First heading. First heading. Cloud cluster. Cluster. First heading. Cluster computing. A cluster is a group of interconnected group of interconnected group of interconnected computers group of interconnected computers working as a single system to perform parallel processing to perform parallel processing. Second one, second the first one. Parallel. Parallel computing also there. I will put it parallel computing. Exactly parallel computing. Parallel computing involves multiple processes. Parallel computing involves multiple processes executing tasks simultaneously. Multiple processes executing tasks simultaneously to solve the problem faster. To solve the problem faster. Next one, distributed computing. Distributed computing. Under this item, distributed computing is a computing model. Distributed computing is a computing model. Is a computing model where a problem is solved by where a problem is solved by dividing where a problem is by dividing solved by dividing tasks among dividing tasks among multiple network computers among multiple network computers multiple network computers. Have you noted Lester? Lester, Lester, Lester computing. Then grid cloud computing. Cloud computing delivers computing services. Cloud computing delivers computing services. Computing services in private network storage from comma networking. The bracket storage, comma processing, comma networking. These are the services we provide. Cloud computing delivers computing services, storage, processing, networking. Bracket close over the internet. Bracket close over the internet. So actually, grid computing also there. Just make a note. Grid computing. Grid computing. GRID. Grid computing connects. Grid computing connects geographically. Grid computing connects geographically dispersed computers. Geographically dispersed computers. DIS dispersed. DISPERST. DISPERST. Dispersed computers to work on dispersed computers to work on a single problem. To work on a single problem. So, if a computer paradigm for normal usage, we use mobile computing, biocomputing, quantum computing nowadays the most popular quantum computing. So different computing paradigms. So all those are coming into the picture to compute and to solve a problem, complex problem in a function manner. The problem P can be solved using cluster computing. Problem P can also be using distributed computing. So can also solve using uh, grid computing. Can also use on cluster computing. Can also use cloud computing. Can also use to solve by quantum computing. So different computing paradigms are there to solve the problem. The difference is that all the paradigms are so the computation efficiency, computation speed. As nowadays when talking about the research point of view, quantum computing. Quantum computing. Quantum computing says that this is a quantum theory. Quantum theory, quantum theory is there. So reason for that there is a quantum computing that it is more fast. It implies a very fast computation to solve the problem. So as we have cloud, still it is coming in the future, then it is computer, then it is quantum. So all this by computing, right? Different computing methods to solve the problems again. The speed. And the second point in this unit, second topic, you can say. So that is technologies for network-based systems. Next, speech ID. Technologies for network-based systems. Technologies for network-based systems. Under this, we discuss the five topics. The first one is multi-core CPU and multi-threading technologies. And also GPU computers to XRPL and beyond. Next one, memory storage and audio networks. Virtual machine virtualization. And the last one is data center virtualization for cloud computing. So here the first one, first topic, multi-core versus multi-threading. Multi-core CPU versus multi-threading. Normally, while you're purchasing a laptop or CPU, personal PC, desktop system, your processor speed will be measured with the dual core, dual core processor, octa core, hexa core processor. Will generally parameter dual core processor. This is octa core. This is hexa core. What do you mean dual core? Dual core 20 core. Ready. Dual core ready. Dual core means processor. Like this is processor. Ready processor. Okay, processor. They go and straight out to you are doing some work. The work can be X. Work will do at a minute. Other 4 X that one. X plus X work is the same way of time. 4 X. Right? Think right X to the habit thing. So we have to ability to take both X. But then both X are ability. So 5 pages, 10 minutes for us, 5 pages, 5 minutes for us. Because there are one more hand is supported. Compliments to us at here. Right? That is dual. The core is the process which increase the computational speed. Computation అంటే complex call process execute. So that execution process, computation process will be increased by adding processor to your CPU. So here first multi-core versus multi-core versus multi-threading. Multi-threading is a software program we can say. Multi-threading is a program where multi-core is a more than one processor are connected to your CPU to perform or to compute very or to solve the problem very fast. So that is multi-core refers to a computer processor that has more than one logical CPU core and that can physically execute multiple instructions at the same time. Thus, definitely it will be executed multiple instructions at the same time because more than one processor leads to instruction one at a period of time. And same like this type of process, if it is formal, this is the capacity, same principle, same properties it is also having. So it is the property that expert one instruction at one minute. The same one more is there. Wait, 1 minute, one instruction will be executed by this process, one more is instruction executed by this process. But I will say at 1 minute, how many seconds will be executed? Instruction two. Because for one process, it is one more is added. At same 1 minute of time, three instructions will be executed. So it is now same time, four instructions will be executed. What is it? What we can say? Unit of time is same, but number of instructions executing is increasing. Means faster performance will be increases because to add a number of faster to your logical CPU. So that is multi-core indicates many number of more than two we have processors like computer system. That is multi-core interface. Whereas multi-threading represents a program that is running more than one core at the same multi. So only one will be executed. Let us do this a task one. A task one to execute it. The task usually any task can be done by any processor. So instead of running this task one under this processor one, what we did is task one can be divided into subtasks. And subtask one can be divided under execution of processor one, that is core one, and core two also two. So subtask three will be executed by core three, subtask four will be executed by core four. Then instead of executing one task by one processor, the task is divided by the multiple core. So that is thread. Multi-threading is a program that can run more than one core. Not only one core 1, 2, 3, 4, under the core 1, 2, 3, 4. At the same time, that process or task will be executed. Multi-threading. Multi-threading under each problem is somewhat divided. We are executing the different multiple processors. if multiple processes are executing the same task, then this multi-threading, which is like a program. Multi-core, like this, looks like feels like a processor, physical appearance processor, CPU. But multi-threading is not like it is just a program. And so just keep aside note of better word conflict. Multi-core means multi-core, right? Multi-core refers to a multi-core refers to a computer or processor. Multi-core refers to a computer or a processor. Theory subject కాబట్టి మనం ఇంకో 4 పేజీలు అవుతే 2 పేజెస్ వస్తాం. రైట్ ఒక క్లాస్ మొత్తం 3 పేజీలు వస్తాయి. బట్ క్లాస్ మొత్తం హాఫ్ డే అయిపోతుంది. పేపర్ పెన్ రాస్తే 4 పేజెస్ అవుతుంది. ఆఫ్టర్నూన్ అంతా సౌండ్ సార్ దిక్కారు అనుకుంటున్నాను. దట్ ఈస్ ద బ్యూటీ ఆఫ్ థియరీ సబ్జెక్ట్ అంతే ఏం కొంత దగ్గర వస్తుంది కొందరు ఎక్కువ కొందరు చూస్తుంది. That all we need to be because it is theory subject. That's all not there, but try to avoid that. So because of that reason, I told you that better to write few running points. A few running points are helpful while you reading books. ఇప్పుడు ఈ సినిమాస్ లో ఎంతసేపు చూసిన బాగా ఉంటుంది. బట్ అదే స్టోరీ డైరెక్టర్ మనం స్టోరీ స్క్రీన్ ప్లే డైరెక్టర్ ఆయన రాసుకున్న స్టోరీ మనం సినిమా ఆయన స్టోరీ రైటింగ్ వాళ్ళ వేరు. రాస్తే 2 minutes అయిపోతుంది 4 minutes అయిపోతుంది 5 minutes అయిపోతుంది. సో దట్ ఈస్ ద డిఫరెన్స్. అందుకే ఆ 100 పేజ్ చదివి ఈ 10 పేజ్ చదివినప్పుడు సినిమా మొత్తం గుర్తొస్తుంది. 100 pages also quick. Whatever you written 10 pages also quick మొత్తం గుర్తుంది. అందుకే మీ రన్నింగ్ పట్ రాసుకుంటే అసలు స్టోరీ ఏంటి క్లాస్ అనేది మాకు గుర్తొస్తుంది. ఆ డీటెయిల్స్ వస్తుంది. So this is multi-core refers to a computer processor that has more than one logical CPU that has more than one logical CPU, more than one logical CPU core, that is more than one logical CPU core, and that can physically execute and that can physically execute and that physically execute multiple instructions at the same time. Execute multiple instructions at the same time. Multiple instructions at the same time. Second, multi-threading refers to a program. Multi-threading refers to a program. Multi-threading refers to a program that can refers to a program that can running more than one core that can running more than one core at the same time. More than one core at the same time. More than one process run at the same time. More than one processor can run. See here, that make recording also learn this you listen. First box, first with the 4 lines. 1, 2, 3, 4, 5. 5 buildings were 5 buildings. First building, second, third, fourth, 5 buildings. Each building lo 4 bricks. Each building lo 4 bricks. Antena? Change the bricks. One is some marked is white and some is with the dark. But ఒక బిల్డింగ్ తీసుకుంటే 4 bricks. you can say it is 4 bits. So this we can say that 4 pipelines data path in each of the following 5 processor categories. Okay, there are 5 processors. These 5 buildings, each building assume that as one process, one processor. That is 5 processors, 5 different processors. Each process of 4 pipelines. That is 4 buildings. So, see here figure 5 processor categories, 5 processor categories, different processor categories. One processor category processor. So, two different categories. So, so we see here first one is 4 issue supervision processor. Second one is 5 multi-threaded processor. Third one is cohesion multi-threading processor, dual core multiprocessor, and simulated multi-threaded processor. So these are the just we wanted to know how many types, just what are the types of processors we have, how these processors will execute by these 4 pipelines. So internally, system on pages will have this. Just note it on this definition, this diagram. So this is what processor we can say. If we can say it is a one processor, then it is a 4 pipeline. That threads are there. We can say T4 thread. Thread also will be acting as a executing a task. So at a processor, one processor will have a 4 threads. Thread 1, thread 2, thread 3, thread 4. Thread is nothing but a program. For example, multi-thread, a program. Program 1, program 2, program 3, program 4 is under execution of single process. So likewise, the different categories of processors we have. At GPU, what is GPU? GPU, so GPU and CPU is there. Not it is typing mistake. CPU. GPU is there. We know.
Continue, sir.
So CPU, what is the abbreviation of CPU? There is CPU అనగానే మన కంప్యూటర్ డెస్క్టాప్ లో పెద్ద కాన్సెప్ట్ that is CPU. CPU contain different peripherals. Simple concept is like one processor actually. The along the processor there are different components available. All together connected in a one box. This is one monitoring of the control. As CPU. So as the CPU, there is a processor. Main hardcore of the computer. That's what the processing unit. It will perform different actions like the control everything. That is CPU. But GPU, CPU అంటే మన ఏ టాస్క్ ఎగ్జిక్యూట్ చేయాలని సెంట్రల్ ప్రాసెసింగ్ ఎగ్జిక్యూట్ చేయాలి. Then what is GPU? అక్కడ ఉంది GPU purpose to అక్కడ ఉంది graphics processing unit. Graphics processing unit. So sometimes you can see GPU system without having any technical knowledge, GPU systems they are more computable facility. Most complex problems can be solved. Like A applications and ML applications, we can run on GPU, which is having more capacity in terms of storage and processing speed. Okay, normal me laptop ఉంటుంది. This laptop we cannot run this gaming. The game in the for gaming purpose, the computer is software. For gaming purpose, you take this laptop. Otherwise, for only normal use, we take this one also. Not even laptop, in mobile also they are saying. What I reason I went to store that I've seen Redmi and so on. So they said, sir, if it is gaming purpose, you take this one, it is flexible. Mobile is used for only gaming and everything. And I lost in that. I'm using it. So such a way technology is increased, but don't prefer mobiles. Mobile support, gaming support చేయకుండా best. అప్పుడు గేమ్స్ ఆడాలి. అప్పుడు మొబైల్ and you like small games also. Right? So that gaming, what does the purpose of saying it is used for gaming? So why, based on what reason he is saying that it is used for gaming? Based on the processor speed, based on the games ఆడుతుంటుంది ఆన్లైన్ గేమ్స్ నువ్వు ఎక్కడ ఉన్నావు మీ ఇంట్లో అబ్బాయి వాళ్ళు ఇట్ డే బోత్ గేమ్స్ ఐ షూట్ ఇట్ ఆడే పక్కన పోతే క్లిక్ చేస్తాం అదర్వైజ్ విల్ సెట్ సైడ్ బై సైడ్ అదర్వైజ్ విల్ సే నీ కమెంట్ షూట్ అంటే గేమ్స్ చెప్తుంటాను పక్కన షూట్ చేయాలి లైవ్ షూట్ చేసి పాకిస్తాన్ రీజన్ చేసినట్టు ఉంటుంది రియల్లీ షూట్ చేస్తున్నట్టు ఫీల్ అవుతుంది సో దట్ యాక్షన్ ఏమంటే క్లిక్ క్లిక్ ఆన్ మీ చేసే ప్రతి క్లిక్ కి ఇమీడియట్లీ దట్ షుడ్ బి రెస్పాన్స్ మీరు చేసే ప్రతి క్లిక్ కి దట్ షుడ్ బి రెస్పాన్స్ అదర్వైజ్ యూ విల్ బి కిల్డ్ బై అదర్స్ అదే గేమ్ లో నువ్వు షూట్ చేసే లోపు బికాజ్ యువర్ కంప్యూటర్ స్పీడ్ ఈస్ లో దట్స్ వాట్ దే ఆర్ థింకింగ్ you this mobile, this processor is capable of gaming. The gaming want to convey this storage for the gaming purpose. We have a large amount of speed. So the same way, not only for the gaming, some technical applications can also should be computed very fast by like AML applications, AML applications, or deep learning applications can require more processing data. So data is more of huge amount of data can be processed, and we need to analyze the data, and from analysis we need to give a response. Because of that reason, there is required more fast, less fast processor. For that, GPU systems are used. The GPU stands for graphic processing unit, which is marketed by NVIDIA company in 1999 only. But now this recently we are talking about GPUs in your education systems, but already in the core industries, GPU systems are there for large amount of data processing. So it is a graphics co-processor that is mounted on a computer graphics card or video card. Okay. The graphics card is the system purchase graphics card, specifies graphics card is company. 2 gigahertz is something. 210 gigahertz is graphic card if it is more fast, then it will be more processing and more flexible for the advanced applications. And unlike CPUs, GPUs have a throughput architecture that exploits massive parallelism by executing many concurrent threads slowly. Instead of executing a single long thread in a conventional microprocessor very quickly. So here the point is normally the CPU, if there is no CPU, there is no GPUs, normal traditional conventional CPUs will execute different kind of tasks or a program we can run. But whereas unlike this CPU, whereas GPUs will have a throughput architecture that exploit massive parallelism by executing many concurrent threads. Whereas GPUs will be executed more number of tasks, massive number of processors or threads will be executed. Means that huge amount of process or data can be executed or computed by using these GPUs unless the conventional CPUs. But conventional CPUs will executed only but one thread at a time, multi threads, or dual core, octa core. And the structure, why it is GPUs here? See, the structure is like this. So where is the left blue color indicated multiple core? CPU, the dual core. CPU is hexa core. CPU is octa core. Octa అంటే 8 cores. Hexa అంటే 6. Dual core. So there are CPUs are limited the number of cores. Whereas GPUs are number of cores, the processors are more than n number of resources. N number of processors. This number is increased, the processing speed is very high. Obviously, the processing speed, the response or the peak response will be expecting from this GPU. So here we can say a CPU consists of 4 to 8 CPU cores, while the GPU consists of hundreds of smaller cores. The NVIDIA and CUDA Tesla is using GPU clusters, high processing systems for parallel processing of massive floating point data. To process this huge amount of data, the CPU, if you use the CPU system, the CPU is restricted for 4 to 8 cores. By using this 4 to 8 cores, the maximum amount of data can be processed very slowly. To increase the processing speed, definitely we go with the GPU systems because as GPU systems, the GPU processors will have n number of and 100 number of cores. Once the number of cores are increased, and obviously we can say that the or processing of data will be or computation or solving the problem is very faster method. By just for these two diagrams, for better understanding, as always we require number of cores, number of CPUs. By observing this, once we remember this, no, you can write at least 5 to 10 lines this diagram. So there are only 4 to 8 cores. As 4 to 8 and the GPU will have 100 cores. Definitely 4 to 8 is very less than 100 number of cores. If it is very less, then computation speed is less. Obviously, GPU more number of processes at a unit of time. Same unit of time is CPU computed very less number of processes. The GPU programming models, the four challenges are identified by recently computing. To compute more amount of data by GPUs, there are different challenges. The first one is energy and power. As we are talking about, so increase the number of cores, increase the number of cores, so that data will be very fast. Execution will be fast. Execution will be, but what if it done? To increase the number of cores, to increase the computational speed, to rest very quickly, the work or a CPU or system can also consumption of energy will also be increased. Definitely. So that is the one challenge to maintain GPU. Like one CPU, it can consume a less amount of energy as compared to the one GPU. So that is the one challenge, energy and power consumption. Memory and storage. As the number of cores are increased, the huge amount of data can be processed. To process huge amount of data, you are able to store that capacity should be created at your end side. Obviously, at the same CPU or same computers, peripherals and same configuration, we cannot compute the more amount of data. To compute or to solve the huge amount of data, to segregate, to categorize the huge amount of data. First of all, we need to load those much of data into your system. Then you should obviously maintain that much of capacity or that much of memory storage. The should increase the memory storage, reduce cost also. That is also one challenge. Make sure that your storage will be increased to have to use GPU systems to perform GPU system complex but very fast. And second challenge we say that it is different storage and concurrency and local. And a concurrency and local is to maintain this huge amount of data is locally also very challenging because to locally need to provide security. And the last one is system related system elasticity. System elasticity is nothing but whenever a sometimes huge amount of data, for example, a machine learning or AI application you want to compute, so obviously you get massive amount of data. For that massive amount of data, you can able to store that much of capacity, storage capacity here. Yes, it is there. You can have a 1,000 terabytes of capacity there, but to compute only 50 terabytes of okay, no problem. 58 terabytes capacity there. And the same way, if it is increased capacity of storing the data, that is processing data will be increased 50 to 100, 100, 200, 500, 900,000. And sometimes the capacity elasticity is there, some automatically it may be increased and automatically it is capable of, it is ability to store more than 1000 of terabyte also. But the provision also be there. That is also one challenge, but we cannot elastic, we cannot increase the size of the capacity to store the units. That is also best challenge because it is not restricted to only 1000 megabytes. Some application will be more than this. Can also be accommodated. These are the different challenges in the GPU. So, how many GPU will use with existing CPU? Yes, President, why not? Last thing I put up is up to 8. Right? So, here the GPU usage in the CPU. As I told you, GPU, see the diagram. In this diagram, the last one, right hand side, CPU on the bottom of CPU is main memory, and this left hand side there is a block. In this block, multiprocessor, one multiprocessor, two, and so on, multiprocessor N. And each multiprocessor will have P1, P2, P3 only process one. So normally in the CPU system, if it is not GPU, in the CPU there is a multiprocessor, means that usually process one will be executed by the operating system, next process two, process three. There is a process life cycle there. Based on the life cycle, each process will be getting into the ready state. One is ready state, one is ready state. Like that, will be executed process by process. If it is multi-process system, set of processes will be executed one multi-processor system, which is more powerful than single CPU, single processor system. Multi-processor means that is multi-processor system. Like LPT store, multi-processor system P1, P2, P3. 3 years. Here P1, P2, P3 multi-processor. So this white box indicates that one multi-processor can capable of executing 1, 2, 3, 4 like set of processes. The same way, one more multi-processor and also capacity. Such a way, there are n number of multi-processors. N number of multi-processors collected together. We can say it is GPU. So this is called device memory. Where under this device memory, this device by using this device memory, these multi-processors will be executed set of processors, not only one process. As like CPU is a four processor executor. CPU multiple processors ఉంటాయి. Multi-processor will execute set of processors. అలాంటి multi-processors n number of multi-processors ఉంటాయి. అంటే జనరల్ you can need 2 release per day. That is normal, 3 release, 4 release. ఇంకొంచెం అడ్వాన్స్ 10 కూడా తినచ్చు. కొంచెం అడ్వాన్స్ అంటాం. డైలీ కెపాసిటీ డైలీ అంతగా కదా. బట్ దేర్ ఈస్ ఏ పర్సన్ అట్లాంటి 10 release 10 release ఒక ప్లేట్ అంటే అట్లాంటి 10 ప్లేట్ ఈజీగా తినడం. సో లైక్ ఇట్ ఈస్ జీపీ. ఒక ప్రాసెస్ ఎగ్జిక్యూట్ చేస్తాం. ఆపరేటింగ్ సిస్టమ్ ఎగ్జిక్యూటెడ్ బై వన్ ప్రాసెస్. ఒక టైం and next another process, another process. That is general concept. However, the past there is a concept is coming into the picture is multiple processor, multi-process system. Multi-process system అంటే నువ్వు పాటలు వినాలి, పాటలు వింటుంది, పైథాన్ ప్రోగ్రామ్ చేయాలి, పైథాన్ ప్రోగ్రామ్ చేస్తుంటే మధ్యలో వాట్సాప్ కనెక్ట్ చేసుకోవాలి, చాట్ చేయాలి, అండ్ ఆల్సో దట్ ఫేస్బుక్ లో పెట్టుకోవాలి, ఇన్స్టాగ్రామ్ చేసుకుంటాం. There are multiple windows can be opened. So multiple tasks. ఇక్కడ పాటలు ఉంటాయి, ఇక్కడ చాటింగ్ నడుస్తుంటుంది, స్మాల్ విండోలు, ఈ పక్కన పైథాన్ ప్రోగ్రామ్. Multi processors P1, P2, P3. 3 tasks will be done. So that is very fast. So it is very easy multi-processor system. So okay, fine. అలాంటి 100 number tasks is normal system, it is not working. So because of that reason, with CPU is equal to GPU. What GPU contain more number of cores. ఇందాక చూసాం డయాగ్రామ్ లో GPU is SW. GPU means that number of transistors are more. CL like yellow color here. Number of cores. ఇక్కడ 4 ఉన్నాయి, 1 2 3 4 ఉన్నాయి. కాబట్టి కొంచెం ఫాస్ట్ అయింది. 4 అంటే ఒక 40 అంటే so obviously it is very fast. So in the same way, here it is one multi-processor we executed in our normal system. So ఇక్కడ phone ఇక్కడ WhatsApp, ఇక్కడ సాంగ్ విండో, ఇక్కడ పైథాన్ ప్రోగ్రామ్ చేస్తాం. సో అండ్ డిఫరెంట్ టాస్క్. ఇట్లాంటి ఒకటే కాదు, ఇట్లాంటి 100 నెంబర్ ఆఫ్ multi-processor exist in one system called that's what this box is called GPU. Where these tasks will be completed and accessed to CPU only. CPU contains main memory. From this memory, it is accessing. So that's what it is. Use of GPU with CPU. And next, memory storage. What are the network LAN WAN manager? What is WAN? WAN. Where it is used? LAN. ఇక్కడ ఈ రూమ్ లో ఉంది right? LAN WAN, those are the network. And also here we see this is the there is a LAN is a first read out. LAN typically is used to connect a client to host base server. There is one server connecting to LAN. So color ఇక్కడ ఉంటుంది and everything is connected by using LAN. Wherever the server is there, we can access it. That is LAN. And next one it is a storage area network. Connects servers to paper storage such as disk drives. SAN LAN and SAN storage area network. Storage area network then we can communicate the disk storages which are not locally, which are far away from you, but those storage areas means disk storage, hard disk or memory storage device are located in different locations are connected to network. That is storage area network. The second one just you read it. Storage area network connect servers. What does servers will have? That to network storage such as this. Along with the not convince SAN and NAS. NAS is the network contained storage connects client to direct this server. So actually the servers the storage area network. The storage network servers are connected to network storage. And here we directly connect to the storage that is called NAS. Network attached storage connects client goes directly to the destination, not through the directly will connect the NAS. So here interconnection of this interconnection network for connecting servers, client hosts and storage devices, the LAN connectors, client hosts and services. The LAN connected servers disconnect. SAN DNS. The LAN connects the storage disk array. Whereas NAS connects clients to the large storage and the network environment. So the difference is that only NAS and SAN through servers we connect the storage devices SAN, whereas NAS network attached storage can be client host can be connected to the direct to the network storage. Whereas next one virtual machines and virtualization middleware. This virtual machines and virtualization. What is virtual machine? Virtual machine is nothing but virtualization. Virtualization is an illusion that there is no physically the memory. For example, virtual memory. So the memory physically not exists, but it looks like the memory is available virtually. So we can make use of that location, which is not meant physically to your inside. So see this diagram. Virtual machines are where offer novel solutions to underutilize resource applications, inflexibility, software usability, and security concerns in existing physical machines. See the first one, these are the physical machines. The first diagram, these one physical machines. In the physical machines, the yellow color represents that. So that is whole, or we can say hard disk drive. Whatever the hardware components, just yellow color represent hardware components connected to your system. Upon these hardware connects, here it is operating systems. Normally in operating system, normally in operating system, there is the operating system definitely it is acting like an interface between the end user and hardware components. So means there are printer is there. If printer you want to communicate with the printer, you cannot directly print out from your Word document. So we need to give a command with control P, that is control P printer, print out new. So control P command transfers your request to the printer. And printer now it will react and start printing. So then from this we can say that hardware component is printer. The software which is your document is a process on your document, Word document, Excel. There is an interface between these two are printing command. The command is passing to the printer by using an operating system. Because of that reason, we can say it is an interface. So not only interface, we can say it is an operating system which enables the users of hardware components. Hardware components ఏవి యూజ్ చేసుకోవాలను దాన్ని యాక్టివేట్ చేయాలంటే కమాండ్ ఇవ్వాలి ఆ కమాండ్ పాస్ చేసి see the diagram all the diagram yellow color represent hardware అవి మన సైడ్ hardware is the your diagram upon the software operating system upon that application is your MS Word MS Excel whatever MS Excel print చేయాలంటే hardware component printer కావాలి మరి ఈ printer కి Excel కి మధ్యలో application establish కావాలి. That is shown the first diagram test it is. What is three boxes? One is application, next operating system, next hardware. So in between operating system and application, there is a dotted line indicates application is separate, that is user inside. Application may be a MS Office, application may be a your notepad, application may be a your Java program, application may be a your Python program, anything. So whatever that application should be reacted as hardware component mediated over all operating system. Second, coming to the second point, this bottom hardware, upon this bottom hardware, there is a virtual machine hypervision. Upon that, guest operating system, upon that, guest apps. So, upon this dotted line is the second one. Dotted line is the first one, the virtual machine, and here is hardware. Dotted line point virtual machine, our guest operating system, guest application. Guest operating system and hardware component. Previous now operating system and hardware component, operating system and application. Application की hardware मतलब operating system. Now it is application is a guest operating system in the top here. This is the guest application. Say like application and your operating system. Between operating system and hardware, there is a one virtual machine. There is one virtual machine. This virtual machine indicates that actually physically it is not exist. Just it creates duplicates the environment. అక్కడ ఒకటి ఉంది అనుకోని చెప్పేసి but physically it is not there. So this virtual machine it will be working called as Navy virtual machine. And one more is called hosted virtual machine, third one. Here hosted virtual machine, here always in hardware, upon this software, host operating system, virtual machine, and here virtual machine coming into the above the data line. So host operating system is there between the host operating system and application. There is virtual machine is coming into the picture. That is host virtual machine. And these are the one more type of virtual machine. The last one is dual mode virtual machine. In the dual mode virtual machine, host operating system itself, this above is yellow color. Above is yellow color. Host operating system itself maintains a virtual place. Again, it is virtual machine, then operating system and application. So these multiple operating system environments exist. Simultaneously on the same machine is called virtual. Host operating system and host operating system. Means there are two kind of operating systems exist in the same system. Two kind of operating system. You can also possible in your laptop also. You can install MS Office for the Ubuntu, Linux, other operating system. You can run on any one environment. So normally in the system, dual operating system on the after booting, there is you can select Windows. If you are not selected, primarily whatever you system is there, it will come into that. So by default it is Windows to Windows 3. In Windows environment, for example, manually you are selected Windows environment. Windows, there is a drive, C drive, D drive, E drive, and your folders, whatever your personal files, C documents, Python documents, everything will be there. In the same system again, to restart, enter into the environment called as other operating system Ubuntu. When you selected Ubuntu also, there also again it shows C drive, D drive, and so on, but not the previous files. Previous are your personal files. So resume of the now in this operating system, but you cannot really look at again separate environment. Main అక్కడ నాకు మెటీరియల్స్ 1 టెరాబైట్ యూస్ చేసిన 1 టెరాబైట్ ఆఫ్ హార్డ్ డిస్క్ లో 50 GB అయిపోయాయి 50 GB సో again is coming to the Ubuntu operating system again it looks like one more computer double not like that actually but it looks like there are two operating systems more than one operating system can be there in a single system then that is called virtual machine and if you want to run multiple operating systems on one machine or multiple copies of the same operating system, then you only have two ways to do dual boot or virtual machine. So dual booting is nothing but when the system starts booting, it is asking that whether you want to select operating system or operating system. It is your option, otherwise you take any randomly. So virtual machines and virtualization pretty well. So here hosted virtual machine is the first one. And next one, second diagram on the right side, native virtual machines. In the native virtual machines, there is different hypervisors or virtual machines are available. Connected virtual machines, Microsoft, right? VMware. In between the physical server, that is hardware. The here it is a hardware component upon these virtual machines, and here different hypervisors are provided virtual machine services. Oracle, right? VMware and so on. But the other side of hosted virtual machines, this native virtual machine, the right hand side, by installed use of virtual machine called hypervision. Privilege mode. The mode we can say dual mode. Previously I said dual mode. So this it is installed by using VMA virtual machine. By using virtual machine only, the native virtual machine can be created and the operating system, the rest of the system. One is actually one operating system. If you want to maintain duplicate same operating system, otherwise you go to the one more type of operating system can be maintained. Or you can say operating system will be Linux and then method will be the work system. See in the left hand side hosted virtual machine, physical hardware upon this normal OS and hardware, then type to hypervision for this virtual machine. These are two different virtual machines and virtualization. So here data centers and virtualization the next one. Before this, just make a note. Virtual machines, and virtualization middleware. Is ready. Virtual machines and virtualization middleware. Virtual machines and virtualization of middleware. Under this, write down 2 points. Under this, write down 2 points. Virtual machines offer virtual machines offers virtual machines offers novel solutions to offers novel solutions to underutilized resources. Novel solutions to underutilized resources. Underutilized resources, comma, application inflexibility, application inflexibility, comma, software manageability, software manageability, and security concerns in existing physical machines. Security concerns in existing physical machines.
Hello. Seminar hall.
Next one. To build
Sorry.
clusters, grids. To build clusters and grids. Clusters, grids, and clouds. Clusters, grids, and clouds. We need to access large amount of computing storage. We need to access large amount of computing storage. Large amount of computing storage and resources. Network resources in a virtual manner. Networking resources in a virtual manner. Networking resources in a virtual manner. Because you want to compute large, you want to access large amount of data, large storage capacity to make it as a cloud computing, to make it as a cloud. So physically we cannot have a large use space. Just by creating a virtualization concept, we make use of that storage capacity, we make use of that network capacity to access data very fast. Next point, multiple operating system environment, multiple operating system environment can exist simultaneously. Multiple operating system environments can exist simultaneously. Can exist simultaneously on the same region. Can exist simultaneously on the same region is called virtual machine. Is called virtual machine. That data center virtualization and cloud computing. Data center virtualization and cloud computing. This is the last one. The second part. Data center virtualization and cloud computing. Data center virtualization means that Data center అంటేనే it is a place huge amount of data can be stored. Data center is a place huge amount of data can be accommodated. So to make it as virtualization, read a large data center may be built with thousands of servers. Means data center, as I said, data center is a place with a huge amount of data. To build the type data center, we have to get the data from the different servers, and we need to accommodate different servers with a more capacity. So, for example, server, there is a one service, the 1,000 kilobits of capacity, which one server is not enough. Such type of service can be both service can be used. Then we can use the data center. Okay? Well, obviously, data center is not usable data. To accommodate usable data, we need to maintain at your side large large number of servers, more number of servers. So then only we can say it is a data center. So large data center may be built with the thousands of or hundreds of servers. The smaller data centers are typically built with the hundreds of servers. So when it is hundreds of servers, this is a smaller data center. If it is large data center, obviously more servers in terms of thousands, you can say. Then only we can say it is a large data center. At high-end switches, routers may be too prohibitive for building data centers. Obviously, to maintain high data centers, we need to maintain routers, switches for interconnecting to provide the data over the internet and over the internet. We need to maintain high-end configurations of routers and switches, and that leads to faster speed. And that is also one factor. Currently, nearly all cloud computing data centers are Ethernet as their fundamental network technology. So nowadays, the existing cloud computing are using Ethernet technology. The existing cloud computing field Ethernet technology to maintain usability of data at their side. So in the see in the bottom, 30% of data comes with IT equipment service and data. The data center you want to establish among these 30% of expenditure should be maintained. That will be decided for the IT infrastructure, equipment services, and storage. Whereas 23% of data can't be children. So 33% of and 80% of data centers for UPS maintenance, 9% for AC, and 7% of data centers last for lighting in the room. So this percentage is tentatively decided that you want to build a big breakfast server and you have to maintain thousands of servers. To maintain those servers, thousands of servers, not only server installation is enough, and you can have a provision to store the data into the server and retrieve the data from the server. To store the data into server, to retrieve the data from the server, again we need an internet connection. For that, host and switches, routers are really configured for the quick response. So network we need to establish. So such a way, these are the under last point. Tentatively, you can say that 33% of cost to build this data center. If it is 100 rupees, 100%. Among the 100%, 33% you have to invest the cost to build. That is IT equipment servers. IT. And 33% for the chillers and 18% for the UPS. Chillers is nothing but equipment, not only equipment, you have to maintain the network engineers and developers, maintenance costs also. And 80% for the UPS maintenance and so on. For 9% of not only to maintain the server, everything should be maintained. ACs are required, power consumption is required, and also the lighting is required. So they're categorized with the how to spend in such a way, not exactly dictating. So these are the benefits for data center virtualization. So data center virtualization is nothing but So I have built this data center not by providing physically by server at your location. General data center అంటేనే thousands of servers ఉంటాయి. Thousands of servers కొద్దిగా పెట్టుకోలేదు. I'll provide for you a data which is they not storing at my side. నా దగ్గర ఉండదు. నా దగ్గర ఉండదు. But I get it from somewhere else. మార్నింగ్ చెప్పినట్టు Netflix is the one software. But they can use it. He is not maintaining any movies. Everything is Amazon services. Amazon uses the cloud provider. The cloud the movies data. Netflix will be tied up with the Amazon web services. End user की where is proper. Netflix from the Netflix I am watching for it. నా పర్సెప్షన్ లో ఎస్ నాకు నాలెడ్జ్ లేదంటే నెట్ఫ్లిక్స్ లో ఇది ఉంది అమెజాన్ లో ఇది లేదు నెట్ఫ్లిక్స్ లో ఉంది అమెజాన్ లేదు సో నెట్ఫ్లిక్స్ దగ్గర ఉంది నెట్ఫ్లిక్స్ అండ్ అమెజాన్ ఫ్యామిలీ యూజింగ్ AWS సర్వీసెస్ బట్ దట్ ఐ డోంట్ నో ఎనీ యూజర్ అంత నాలెడ్జ్ లేనప్పుడు మనం నెట్ఫ్లిక్స్ లో అంటే నెట్ఫ్లిక్స్ ఇది ఒక ప్లేస్ ఒక సాఫ్ట్వేర్ ఒక ఇండస్ట్రీ అక్కడ నుంచి కావాల్సింది but Netflix is a one data center having virtualization concept. Virtually, physically it is not there. Virtually is located somewhere else that we will extend. అక్కడ నుంచి ఇక్కడ తీసుకొచ్చి బట్ మనం ఏమనుకుంటాం ఇక్కడ నుంచి వస్తుంది అది డేటా సెక్టర్ వర్చువలైజేషన్ వాట్ ఇస్ the data center virtualization the first one reduce hardware vendor logging hardware maintenance తగ్గిపోతుంది and the improved disaster recovery. If your roof is collapsed, your building is collapsed, and data may not don't data anything because data is not losing because you are not physically maintaining servers at your side. And we are virtualized, no? So somewhere that will be there. And next one is smooth migration to cloud. Smooth migration to cloud. So it is not user interface. It's already somewhere. We can migrate from one cloud to other cloud. There is different type of clouds are there. Cloud, for example, Amazon cloud we are using. Now up to as of today, still last 2 years, Amazon I'm the using of Amazon services. I provide a paid some amount of to that. I'm using that space. Now I wanted to change Amazon to the IBM cloud. So same data, then I will give it provision to whatever the data is there in Amazon service to locate into the IBM cloud. So it is moving from one cloud to the other migration. That is easy, very easy. They will take care of. It is not works. And also the reduced data center footprint. So data center you can discover hospital. Like faster customer provisioning. Obviously, which is virtual machine not at your side, and obviously that will be very fast and thing. These are the key benefits for data center virtualization. So these are the 5 points. So wanted to discuss the technologies for network based. What are the points? Multi-core CPU and multi-threading technologies, GPU computing, Excel and Excel beyond that, memory storage and wide area networks, virtual machines and virtualization middleware, and also data center virtualization for cloud computing. This is only 40% of first year. 40% to 50 sometimes. Right. The next topic.
మా వింటున్నారు అందరూ నాకు ఏ ప్లేస్ లో కూర్చోబెట్టి ఆ ప్లేస్ లో ఎక్కడ లేదు అసలు ఏం చేస్తారు ముందుగా కూర్చుని ఏం చేస్తారు
CPU abbreviation. GPU. Graphical. So how many cores are there in GPU? GPU, how many CPUs? Hundreds of cores. We have one seen one diagram. There are 4 to 8 cores are there in a CPU. So this one. GP is the right side one. 100 number of cores. Hundreds of cores are combined. Then we can say it is a GP. Right? So what is the parallel computing? What are the service models cloud computing? Service models. Three types of services. Anybody from this set? What are the different services provided by the cloud? Cloud నుంచి ఏ సర్వీస్ మనం చేసుకోవచ్చు? SAS, PA, IS. What is SAS? Software as a service, platform as a service, infrastructure as a service. What do you mean by software as a service? Software as a service, okay? So at the user end, you want to create a poster. There is one software tool is required. No need to buy that software tool. Just the tool is available in the cloud. Just download the cloud from the cloud and make use of that software and use for your requirements. A software download చేసుకో నీకు కావాల్సిన fulfill చేసుకో. So such type of softwares are provided by cloud called as one service, software as one service. Infrastructure. These site servers maintain చేయాల్సిన అవసరం లేదు. Right? GPU. You want to run a machine learning application by using regression algorithms, random forest algorithm. You made different one big application. So you are using all machine learning algorithms for optimizing techniques, whatever it is, the purpose. You want to run that application. To run that application, the very fast processor is required. But as an app user and then just as a student, so we cannot able to purchase. So then we need cloud service. In the cloud, there is a provision, there is service exists that one platform it will be provided. On which platform you want to run your application. So my application required this much of this type of platform is there. So like one CPU or GPU types of. So that is infrastructure I want to maintain. That much of CPU, that much of large processors, I am unable to purchase. So to use that fast processor, there is a provision in cloud. So just we pay some amount and it is GPU services can be used. So your application can be run as infrastructure. Platform. So I don't want to compute database of Oracle database. Purchase in version. I'm using Microsoft Office 365 and I'm able to purchase. But I want to make a colorful PPTs, which is the existing free version, which is not satisfied. Take making. So because of that reason, total cost, for example, to subscribe still for this MS 365, Microsoft 365, that has been 2000 for 1 year. But I have offered 2000. Then simply they will charge us for 10 days trial 100 rupees. For 10 days 500. So definitely I go with this and I pay this 100 or 200 rupees and I'll prepare my just one document for a colorful manner. Just leave it. 100 rupees, 200 rupees I pay, paying 2000. So that is platform as a service. That platform, our platform uses for colorful documents. That is platform as a service. These service models and also deployment model. Public, private, and hybrid. What is public? Public content? RTC. Public content? Public is like anyone can access the service of the cloud, public cloud. So whatever the services, just be paid and use. Not is dedicated for you. Anybody can access. Whereas the private, once they are paid for your service, that service is truly dedicated for me. And the car will not be car makers. Your own car. No way you own. Whereas hybrid is more costly because now work car ఉంటే నేను 1 లీటర్ పెట్రోల్ పోసుకుంటే ఎక్కడైనా పోవచ్చు. But అదే హైబ్రిడ్ అయితే like it is tax free, rented tax free. So it is sometimes it is like a and it is like a personal vehicle. But to act as a, to feel like a personal taxi, we have to spend much amount of time. అదే కదా కాకినాడ కాబట్టి 200 రూపీస్ క్యాబ్ తీసుకోవాలి. అదే 200 ఎవరు పెట్టలేదు అంటే 50 వరకు వెళ్ళచ్చు. So that is the difference. But it is also feel like your own vehicle during this time, during that 20 kilometers of this day, you feel like you are on this car. Driver is driving, you are sitting in the back side of the taxi. That is hybrid. Later, the same taxi will be in the you have to know what to do, you have to think about it. That is hybrid model. And then the services provided by this, you have to pay during that amount of time only it is dedicated to you, later it is public to everyone. Later it is public to us. So the community is the most important than the user even what are the different ones, what is the later service models, right? What is cloud computing? And then you are totally considered cloud computing, central computing, distributed computing, as well as grid computing. But if there's no diagram book for it, then what you process it. Right? So can I start next one? 4:30 of 4:30 of 4. 2:30 వరకు ఛాన్స్ లేదా? ఇంకా 10 minutes ఇద్దాం.
రేపు మార్నింగ్ ఈరోజు ఫ్రెండ్స్ ఎవరైతే రావాలో వాళ్ళు కూడా తీసుకెళ్ళి ఇంకా రావాలంటే